On this lesson, we're going to be looking at cubic and cube root relationships. So remember, we've discussed inverses before. Inverses, remember the x's and y's are switched because it's a reflection over the line y equals x. So it says inverse relations. Interchange the x values, which are your input, and the y values, which are your outputs. So a relation and its inverse reflect over the line y equals x. Inverse functions undo each other. An inverse function is an inverse relation that is also a function. So the process for this, to find the inverse from an equation, we've talked about it before. Make sure you change your f of x to a y. You're switching x and y, and then you're solving for y, and then you're going to rewrite it in function notation if needed. So the inverse of f of x is this symbol, and it is read as f inverse of x. Okay, so example 1, we're going to find the inverse of f of x equals x cubed. Notice that is the cubic parent function. We're going to graph the function and its inverse on the same graph. So first thing, I'm going to write f of x is y. Then we're going to switch our x and y. And then to get rid of the cube to solve for y, I have to take the cube root of both sides. So that leaves me with y there. So the inverse, instead of y, equals the cube root of x. I just rearranged that. So if I have x cubed, the inverse of that is cube root of x. So I'm going to graph this one first. So remember, we plugged in -2, we got -8, -1, -1, 0, 0, 1, 1, and 2, 8. So there's my function f. And then plugging in or graphing cube root of x. Remember, we know that one too. That is -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So this is our inverse graph. Okay, so you could also notice that our values, if you look at each point, like this point here was 2, 8. So 8, 2 would be your inverse point. So notice those points are just switched on the inverse. All right, let's look at the next one. So this one, we are starting with cube root of x. We're going to graph the function and its inverse. So first thing, I'm rewriting f of x as y. And then we're switching x and y. We're solving for y, so in order to get rid of the cube root, we've already discussed, we cube both sides. We get x cubed equals y. And then instead of y, we're putting inverse of f. So graphing your original, which was the cube root of x, so -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So there's my f. And then my cubic, so that is -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So again, those points have just been flipped. That is my inverse. So it says, make a conjecture about the relationship between your cubic and cube root functions. You can easily see that if you have cubic, the inverse of that is cube root, and then vice versa. If you have a cube root, the inverse of that is cubic. So it's like the opposite here. And notice we said earlier it undoes each other. All right, on the back, we're going to find the inverse f algebraically. So very similar to what we were doing on the front. So first thing I need to do is change my f of x to y. And then switch x and y. I'm having to solve for y, so I'm going to subtract 7. And then to get rid of the cubed, I'm going to take the cube root of both sides. And then that just cancels out. That leaves me with y minus 2. And I have to get y by itself, so I need to add 2. So my y equals cube root of x minus 7, and then we're adding 2. And then make sure you do inverse notation at the end. Make sure that that's a plus 2 on the outside. So there's my inverse equation. All right, let's try another one. So same thing, we need to replace f of x with y. Switch your x and y. Notice to get y by itself, I have to get rid of the cube root before I can do that, so I need to cube both sides. And then getting y by itself, subtract 9. So I have x cubed minus 9 equals 4y. Divide everything by 4. And you get y, or f of x, equals 1/4 x cubed minus 9 over 4. Okay, so looking at C, same thing here, we're finding the inverse, so we're going to switch that this is a y. Make sure you switch x and y, don't ever take anything with it, just replace the x with y, the y with x, and then get y by itself, so subtract 6. Divide by 8. So we get 1/8 x minus, I'll go ahead and reduce that. That will be 3/4. And then to get rid of your cubic, we'll have to take the cube root of both sides. Okay, moving on. We are not going to do this one. This last section, we've talked about it before, verifying inverses. You can use composite functions. So you take one function, plug it into the other, make sure it equals x. Same thing the other way. All right, so we're going to take g and we're going to plug it in for x here. So I'm going to have cube root of x minus 8, and then it's cubed, plus 8. So again, I'm taking this, substituting it in for x. I have a cubed right here, and I have a plus 8. So that would be x minus 8 plus 8, which equals x. So that one works. Now I'll do the opposite. Now I'll take this one and plug it in for the x there. That's going to be 8 minus 8, 0. So cube root of x is x. So that one works. So yes, these are inverses of each other. Okay, so you're having to do the same thing on the next ones. So I'm taking this whole thing, plugging it in here. So I have cube root of 2 times 1/2 x minus 8 cubed, and then plus 8. So those cancel out. We're left with cube root of x minus 8 cubed, which is just x minus 8 plus 8, which equals x. Do the opposite. Take this, plug it in for this x. Those cancel. That gives me a 2x times 1/2, which just equals x. So yes, these are also inverses of each other. Okay, and the last one. So we're taking this one, plugging it in here. So that's cube root of x plus 2 minus 2 cubed. So we have, notice here that these do not, we can't combine those because one's inside, one's outside. That is not going to give us an x. So therefore, no, these are not inverses of each other. If that was not under the cube root, then we could cancel those out. It would be just x, but those you cannot combine. All right, if you have any questions on inverses, let me know.